No, it's a concha. Okay.
Huh?
You'll see it? Right
Where?
there. It's right next to my backpack. Yeah, I know what's good. Okay, just giving you a heads up for this week and next.
Concha?
You want me to say it worse? Concha?
No.
Yeah. That's right.
You're a disgrace, child.
That's right. You want me to say it worse? I can say it worse. I think we had this yesterday, the quesadilla. Yeah, I can say it worse. Taco, tamale. Yeah. Okay. Anyways, here's the I guess 2-week overview, right? We're gonna do chapter 8.1 today, tomorrow. Today's gonna be a little lengthy. Tomorrow should be all right. And then Friday we'll start reviewing for the rest of chapter 7 test quiz. And then Tuesday will be practice quiz. And Wednesday real quiz, right? Forgot to write it there. Okay. So there's all that. And then Thursday, Friday, some more chapter 8. Chapter 8 is very short. We only go up to 8.4, then we're done. So if I were to maybe say about the week after, it might be a quiz on that week too. Okay? Just, just gotta get you guys ready, right? Alright. I don't usually do this, but here's a warm-up. Take like 4 minutes to do it. I know, but this will help you. Maybe, I guess, to spark something. Do you guys remember how to do something like this?
No. That's the cross multiplication.
Cross multiplication. And some people told me in middle school they learned about like a butterfly.
What?
The what?
What the fuck is that?
Okay, so if you remember cross multiplication or whatever your butterfly was, you do this. And then you multiply across.
You shut up, bro. Explain it. Sorry.
Okay, you multiply across. And then you solve for x. Okay, so that's to get you guys started. You two stop. I know, just stop. Okay.
This is Morale's favorite. Morale. I'm being racist, Morale. Remember these used to be your favorite? You remember? You used to choose these. Fucking what? You know my dick already, like. Jeremy, you were on dick today. I know, why are you thinking with a microphone?
It makes you count or what's the fuck?
What do you?
Huh?
Huh? Who's he picks the shoe? Huh? How many penalties is 3.
I
Five.
can have it.
So that's not 5. Every time I play FIFA, I always have to. How about Decker? How about Decker?
We do the world a favor.
If you pick with those on, I swear to God, I'll beat your ass. Like, fucking brass knuckles, like, I'll beat your ass.
Okay, so I'll click on YouTube first.
Mr. Jones, so
Alright, so if I do, huh?
I think I did it.
The first one be 3x over 20.
I got 20 over
3x over 20. Very close. Close? So what I'm doing is I like whatever is on the bottom, right? The denominator will go multiply those up there.
So it's 20 over 20.
So 20, and then this is 3x.
Oh, so it's
So you got 20 equals 3x. The equal sign does not disappear, okay?
Why was that even more complicated than it was?
The equal sign does not disappear. But and then you need to divide both sides by 3. Okay, we'll leave it as a fraction. Okay? Which is 6.6666.
nothing about that.
Okay.
I got x equals x. Of course I'm gonna.
Okay, well, what about number 2? 14 equals 6x.
That's it. And then 14 over 6 equals x.
Good. Okay, but even when you're here, 14 over 6, are you able to simplify that fraction?
Yeah.
Yeah, by what? By 2. 7 over 3. Okay, so I think we are at the, we're at the place where you should simplify if you're able to now. Okay, I know before, like last year in algebra 1, if some of y'all gave me this, I was like, sure, I'll take it. But now we have to simplify if we can. Okay? No? I don't go crazy. Alright, so here's day 1, chapter 8.1. Okay, similar figures. Get down title and then I'll scroll down to what you actually need. What? Huh?
You didn't hear that.
Oh, she's in this. I didn't know. I just moved on.
Okay, y'all got the title? Huh? Yeah, the green one. Okay, this is the big idea here, so. Find it funny how they call it big ideas.
You're so.
I don't know why they call it.
You know this?
You're dumb.
Why they call it that? Big idea.
Today's Wednesday. In the house round because there's
Big ideas.
But what time we play? You
And
gonna
it's
go?
math.
Fuck no, we're leaving at 2. Oh, we gotta what is that? That's lunch? What? 6 period. But I'm one, yeah, one thing I'm, no, wait, I'm one of the highlights. This, yeah. Shows fucking independence. She wants to come, but I can't, I don't go back to work today. She texts his guest too. Something has something.
good? Yeah? Alright, so these points here, right here, they're gonna carry you through the bulk of our problems. These two need to be true for figures to be similar. Okay? So it has to have same ratio, proportion, scale factor, etc. Right? They're all pretty much the same. Basically the same. Okay? If you go into detail, they're a little different, but they're basically the same idea right here. This one, congruent corresponding angles. You guys should know this one. Okay, so wherever the location of the angle is from one, go to the other, they have to be congruent. Okay, or else this will not work. Okay, you'll see that later too. Alright, so you need both. If you have one, but not this one, does it work? No. No, you need both. Okay, so both of these have to be true. Okay, so we'll see that. Here's the first example. It's gonna get a little crazy, but I need you guys to be patient, okay? Yep. Oh. I think this might be a new symbol. A little tilde. Right? Yeah, so what this is similar to. Okay, I know in one class I mentioned it, but not too sure, so I'm gonna say it again. Are you done? Good? Yeah? I'm gonna have you guys copy down this little part A as well, so we can look for the ratios. Okay, so part A, copy this one. Okay, so we're gonna follow this direction, right? It says to find the ratio or scale factor from triangle RST to triangle XYZ. Okay, so the way I kind of deal with this is identify which one's the bigger triangle and which one's the smaller one. Okay, RST, is this the bigger one? Yes, right? XYZ, this one is the smaller one, right? So if they're saying scale factor from one to another, are you going from big to small or small to big? Big to small. Okay, I would actually like say, tell yourself that. Because if you tell yourself big to small, small to big, you know what your ratios should look like. Okay? Say you start with something big and you shrink down to something small. Are you multiplying by a number bigger than 1 or smaller than 1? If you multiply by any number bigger than 1, aren't you making things just bigger? So if you want to make something that's already big to get smaller, your value should be under 1. Okay, you're shrinking it. Okay? So that's the idea I want you guys to think about right now. Okay? If we're gonna set up ratios and I want that number to be under 1, how am I gonna set up my fraction? Okay, let's just take a look. So You guys know in the triangle you have like the longest side, smallest side, and the medium one, right? You guys want to look at the longest ones first? So over here, the longest one is 30, right? Okay, what about in the smaller triangle? Which one is the longest side? 18. Okay, now like a little side question. Would it make sense for me to compare the longest side over here to the shortest side over here? No, there's like no correlation, right? Okay, so you gotta, match those up. Okay, if I'm gonna make this ratio go from big to small, I need a small number. So what I'm gonna do is I'm gonna set up the smaller side, the longest side on the small triangle at the top, and the other related one at the bottom. Okay, which is TS, yes. Okay, now that you have that, you go plug in your values. You have 18 over 30. Okay. What is that simplified? 9 over 15. Can you keep going? 3 over 5. Okay, that is simplified right there. Okay, but it's not good enough to just do the longest side for each. Okay, you have to go do at least 2. Okay, so since we did the longest ones, should we go look at the shortest ones? We have RS and XY, right? Okay, can you guys help me out? What is my fraction gonna look like? Or what is my ratio gonna look like? XY over RS, which is 12 over 20. Eli, well, what can I divide both numbers by? 2. If you do that, you get 6 over 10. Can you keep going? Yeah. You do another 2, which is 3 over 5. Okay, so far, you guys see that the ratio is the same?
Yeah.
Yes, those numbers are the same. Okay. Just to be safe, do the last one. So it should be xz over tr, which is 15 over 25. Yeah. What can I divide both numbers by? 5. So you get 3 over 5, right? Okay, so all 3 are the same, right? Okay, cool. That means ratio is the same. Okay, and your scale factor, how you're gonna write that is you have it be k is equal to 3 over 5. K, scale factor. That's the variable that I think even the sciences use for scale factor, if I'm not mistaken. That's what I've seen it as. Okay, it's just a variable. You being serious? Okay.
That's what you told me.
Oh, really?
Yeah,
Great. When was this?
last semester.
For what?
I don't know, I forgot. I didn't really pay attention. I just wanted to finish that part.
Okay. Okay. So what about if you had like a different case? So I guess what, case 2? What if you went from like small to big? So small to big is triangle XYZ to triangle RST. Okay. Do you really need to go and find the ratios again? No. Is there like a little trick to it? Flip it, which is called, starts with an R. Reciprocal. Reciprocal. Okay. So for scale factor, if you're going from small to big, right? Scale factor should just be the reciprocal. Okay. So just, make sure you know which one's the small one and which one's the big one, and which direction they want you to go in. Okay? Okay. The second part is you gotta list corresponding congruent angles. Okay, so what's corresponding to angle T? The angle. Like what's corresponding? Z. So angle T is congruent to angle Z. And then what else? Angle R and X, and then angle S and Y, okay? So R, X, S, Y. Okay, if it's a little confusing, we'll make sure you understand within these next two. Okay? You guys ready? Yeah? Alright. Okay, so here's some more examples. What? It's just rectangle. You guys ready? Okay, so you gotta find the ratios, right? So you get to choose. You get to go from big to small or small to big. What do you guys want to do? Big to small. So if you're gonna go big to small, your ratio should look like a fraction, right? Like less than 1. Okay, I think you went from small to big. It's the same. It's the same thing. Okay, you can do either one. Okay, but for this example, we're gonna go big to small. If you're gonna go big to small, yeah. Okay, we should start with which side at the top. Huh? The smaller ones. Smaller ones. Okay, so choose one. 2 and 6, which is EF over AB. Okay, Eli, you got me for the next one, okay? So that's 2 over 6, which is 1 over 3. Okay? What's the next ratio? HG? We don't need HG.
I'm sorry, my bad.
B and C, where does that go though?
On the top.
On the top?
Wait, on the bottom.
On the bottom? Okay, so what goes on top? You wanna help him?
FG.
FG. Okay. So you go 3/9, and that simplifies to the same thing, right? Okay. So if you did the other case, if you went from small to big, your ratio should look like 3/1 or just 3. Okay? So either way, same thing. Okay? So those are the same. You will check this off. That's one check. You need two checks, right? Okay, your second thing that you want to look for is congruent corresponding angles. Is that true?
Yeah.
Why?
All 90 degrees.
All 90 degrees. You can't go wrong. Okay? It's a rectangle, right? So they're all 90. Okay, so are they similar? Yes. No such thing. Not yet. Not until pre-calc. The two rectangles are similar. Okay, and of course there is a lazy math way to write it. Okay, so you say yes, rectangle A is similar to rectangle B. Okay, you don't need both, right? You just need one of them. You choose. I give you both. Okay? Are you guys good? Yeah? Okay, stare at the screen more. This one's on you. Okay? I want you guys to try this one. Answer the question. Are these two parallelograms similar? So that means you're gonna check for the same two things. Okay? So I'll leave this here. So find the ratio. Yeah.
The angle like on the inside don't matter.
They do matter. That's part of the trick. Okay? So find the ratio, see if the corresponding angles are congruent. Alright, I give you guys like 4 minutes. Okay, work with each other. It's not a solo thing. Talk to each other. If you're a little lost, you should ask your friend. Get to work. Look at him. That's what he does all day.
What?
What? Okay. Sure.
7.5 goes into 15. Oh, yeah. Fuck. Yep. Yeah. She following me? You could just like say something, you know.
That much. That's the right channel. Yeah, you can turn the top. Okay, you see that? Right here.
Mr. Chow,
Yeah.
I'm just a little confused what we're supposed to do with the angle that's inside.
You're supposed to try to find the missing ones.
I know that, I'm just.
How are you gonna find the missing
Other
ones?
examples when you never did an example.
We've done these before. In parallelograms. How do you find this angle right here? If this is 120, it's supposed to add up to 180.
So it's 60.
So it's just 60. So then this is 150. So are they similar or not? Why not?
Well, wait. I just a question you just
Huh? If okay, well, did you find the ratios?
No, not yet.
Okay, well, for those of us who found the ratios, what is it?
It's
1 over 2 or 2. Okay, can we all agree? Do I need to show you how to find it? I'll just do 1, okay? So you do like AB over EF, that's 15 over 7.5.
That's 2.
If you throw that in the calculator, you should know that that is 2. Okay? You get the same thing if you do, AD over EH, 4 over 2. 4 divided by 2 is 2. Okay? Yeah. But when we go look for the second criteria, right? The corresponding, congruent, you can switch the words. Congruent, corresponding. Are they congruent?
Yeah.
They are? So if you go corresponding, angle C corresponds to what angle? G. Are they congruent? No. So even though this, yes, this one is no. So are they similar? No. Did I use A and B? Yeah, so no. Parallelogram A is not similar. Parallelogram B. Okay, done. So does that mean you always have to start with the ratio? No. No, you don't. Okay, so if you find one to be wrong already, go pick at that one. Huh? No, one more. Last one.
It's pretty easy, Mr. Chow.
Okay, then this next one you got me, right? All right. Okay, last one. There you go. I think these types of problems are the bulk of your problems. Okay. The other ones is just to get you to go get here. Okay, we have a copy down? Yeah? We start off with saying that they are similar already. So what two things do you know? The what? The rectangles are similar, which means you know the two things that we've been trying to show, which are that the ratio has to be the same and the angles, corresponding congruent angles. Those two you know automatically from that. Okay? So if I say the ratios have to be the same, don't the ratios have to be equal to each other?
Yes.
Okay? So set them up. So if you set up the ratio to be like AD over what? EH, it has to be equal to the other one. What goes on top over here? You already used 18.
Well then,
36. You used 36 as well.
oh, sorry.
HG? Where's that go? The bottom? What goes on top? DC. Good. Okay. So you will, substitute everything in. AD is 18. EH is 36. DC is X. And HG is 54. Now this looks like the warm-up, right? Okay. So you can either cross multiply or you can just multiply 54 or use a calculator. Okay. What do you want? You want a calculator way or no calculator way? I'll show you really quick. You don't have to think too much about this. 18 over 36, isn't that the same as 1 over 2? 1 over 2, right? Yeah? Same as 1 over 2. Okay, if you multiply both sides by 54, basically what you're doing is dividing 54 in half, which is 27. Done. Okay, if you wanted to do your cross multiply, you can do that too. You just got to use a calculator. Number's too big. Okay? Any questions? We're good? All right, we're done.
Okay, we do 5 6.